You're all in Palace 1, getting ready to see a talk by Colin Moliner from the Berlin Institute of Technology on probing mobile operator networks.
So, hello everybody. So, just a short introduction about myself. So, I'm basically a security researcher. I'm from the Technical University of Berlin in Germany. I recently got my PhD in computer science, and my special field is mobile handset security, but more like in the last years, more cellular systems in general. In the years before, I did some stuff with Bluetooth, a lot of stuff with SMS, MMS. And yeah, as you saw earlier, I also did some work on NFC. So basically, I will go through some history and motivation, then how to probe, why to probe, and some results and more results, and basically just a lot of interesting things I found. So in 2009, I started scanning for public IPs of mobile network operators because of this whole SSH thing and jailbroken iPhones. And I didn't do a talk because in late 2009 there was this IKEY worm thing, which basically exploited exactly that fact. So I didn't really have anything to talk about, but I kept looking. For me, the interesting thing is that actually 1 year before this IKEY thing happened, I wrote this nice blog post on my weblog about like, hey, maybe you should disable like SSH on your jailbroken iPhone when you like go through like computer security events where you actually have some people who can like type a few lines of SSH parameters. So this was quite interesting. So that's more or less how I come to like scan for mobile devices. So, but the general motivation for me was, okay, how many devices are on mobile networks today? What kind of devices are there? What are the security implications of these connected devices? Because many of those devices which are connected to those networks are probably not seen as being a part of the internet. And what are like devices in terms of hardware worth looking at? What are like starting points for next projects? And just maybe some general forecasts on what mobile networks are going to be used in the near future. And people really have interesting or strange ideas about that. So what are we expecting to see here? So this talk is not about mobile phones. It's not about the mobile phone in your pocket. It's about mobile devices that are connected to networks. And one interesting point was, hey, does the mobile network operator actually know what kind of devices are connected to their network? Maybe they don't want to know because maybe then they're liable if something really bad happens. So that's kind of what I'm going to talk about. And yes, this is like a really simple, plain, boring IP port scanning talk. I always want to do like a port scanning talk, but 10 years ago it was like already boring, and I'm a mobile guy, so I thought, oh, okay, let's do that some years later on mobile networks. And so the actual scanning technique is nothing new. It's more about the results. The scanning technique is like probably the worst you ever have seen, but this is not about the technique. It's about the data and the results. So when you look at a mobile network, basically you have like a core network and a few cell towers, and you probably think that's how the network looks like. You have a bunch of mobile phones, smartphones, then maybe your 3G or 4G connectors for your notebooks. And basically, yeah, if you think, what is a mobile network? That's probably what you think is connected to the network. But there are probably many, many more kinds of devices, and that's what this talk is about. So when I started to think about that, I thought, okay, well, how do you find these other devices? Okay, you take your laptop connected to the mobile network and start like scanning like the IP range you got dropped into by the mobile network. But as it turns out, that's actually not really worth doing, because a lot of how connectivity works depends on the access point name or the configuration. The most important thing is inter-client connectivity allowed? If it's not allowed, the scanning will never work, because you're not allowed to connect to other clients, no scan. So also, if you scan this way and you want to scan different operators, you have to get a SIM card for each operator. And that of course involves money, because you also have to pay, even with like data flat rates or anything, you still have to like get the plan with a flat rate. Also, if you want to look at operators in other countries, you have to like, if you don't want to like travel to that country and do local scanning, then you have to like do scanning from home, and then yeah, you have this like small problem called roaming charges, which probably many of you know what that are if you like traveled from some other country to the US for this event. So we really don't want to do that altogether. But if you decide to do it, which I didn't, then there are some things to look out for. For example, special APN names that's used in like specialized devices, like for ebook readers, which I had talked a little bit about in 2010 at CanSec. Or if you have a machine-to-machine device, so some industrial device which comes pre-installed with a SIM card, maybe it makes sense to disassemble that and look at the APN configuration. Maybe that you can learn something from that. So you basically, get hardware, extract SIM card, get the APN names, get the configuration, and then scan. So if you want to do that. But actually, what I actually did is just scan from the internet, because it gives you a lot of results. You don't have the problem of costs. You don't have the problem of speed and parallelism. It just works, and when you see what kind of devices are publicly reachable, you know that the other scanning thing is not really a big problem. So what I basically did to scan, I went to RIPE, so one of the big databases. Actually went to RIPE, but yeah. If you want to find IPs, you can look in the regional register databases. There's like RN for America, RIPE for Europe, or you could try stuff like, let's go at the scan list from like iKey. But it hit a number of phones in different countries, so they probably have a good number of IP range lists. Web server logs, if you have like a web server and a lot of visitors for mobile phones, you can take that and try to extract ranges. Or you just like Google and see, like if you type like AT&T GPRS IP and then you find like some public IP ranges, or you can do that for like any operator. But I was, kind of lazy, so I just went to RIPE, did a full text search for a couple of search terms, basically GPRS, GGSN, which is, so the GGSN is the GPRS support node. It was just like some term you pick up when you do mobile phone stuff, but the search terms are not that important, or M2M, like the machine-to-machine stuff. You get a number of IPs, so I just stripped all the double IPs, came to about 9 million IPs altogether, which is not that much. And one of the big problems is that operators don't like mark their net blocks. So they don't say, hey, we own this net block and it's used for our GPRS devices. Some operators do that, but if you have mixed operators which also have like landlines for like their landline customers, it could be that an IP range that is marked as GPRS will still be like used for DSL because they didn't care about relabeling it. Also, a net block could just not be labeled for GPRS, so I will never find it with that. This is just some basic problems about this technique, but just to know, just to show where the boundaries are for what I did here. And of course there are more problems, especially the network address translation, which is pretty commonly used for mobile networks, so you don't get a public IP on your device. And of course, if the device doesn't have a public IP, you will just like scan against NAT. But it turns out that devices that are actually reachable are the devices you're interested in, because, yeah, for some reason they're reachable on purpose. Also, most mobile phones actually don't run services. So a default Android phone, for example, doesn't have a service. iOS devices are a nice exemption because they have this iPhone sync service, which is like some 60,000 port, which is really nice because you can easily identify iOS devices by simply checking if that port is open. Of course, it could be another device too, but on the mobile range, it's pretty forward that it's one of those devices. And more problems. So of course, GPRS is very slow, so scanning will take some time. That's once because of the bandwidth. It's just it's a slow connections. Also, if a device goes into sleep mode while it's connected, and if it gets a packet, then the device has to be paged and has to be woken up. So it's a really, really long, tedious process sometimes to like actually get to a device. And another problem is devices move around in the network. Sometimes they get disconnected because maybe they like go into a tunnel or into a building, then they get a new IP address. So we'll have problems like that you will scan devices multiple times, maybe never find a device that's otherwise totally normally reachable. And of course, the usual problem when you like scan big net blocks is that maybe your scan like lights up in some IDS of some operator. So these are more problems. So now to the really like disappointing part. My scanner is like a really, really basic TCP connect scanner implemented in Python, and yeah, I implemented it in Python just to. Yeah, it's really fast and like to build something. And for scanning, I actually use Tor, which I will gonna explain on the next slide. It's a basic banner grab. So connect to a port, send something meaningful for that port, and then grab the response and store it in a database. Of course, yeah, randomize the IP address list so you don't like scan 200 devices in one subnet, because that will surely light up in some way if there's some monitoring. So why would I want to use Tor? Of course, I don't want to disclose my IP address because we are sponsored by like the lab I work for is at the university is partially sponsored by a mobile operator, and would kind of look bad if like one mobile operator like goes out and scans everybody else. So since I'm not like employed by that operator, but I'm kind of associated with them, so just to be nice to like our sponsors. Also, you automatically get different IP addresses, so it's like a little bit harder to be blocked by an operator like detecting your scan. And I'm kind of like sorry to like suck up a lot of bandwidth over a long period of time, and I know like Tor has like limited capacity, and everybody of course should like run a Tor server or a Tor node. So I had to decide what kind of ports I want to scan, because when you do a TCP connect scan, you don't want to just like scan all ports, because it will take an enormous amount of time. So I decided, hey, just go for these really, really basic services. At some point I decided, okay, I don't really need to scan HTTPS. Also, I don't need to like do SNMP, and this port 8082. Apparently, some devices use it to like host the TR069 service, which is like some remote firmware thing, but I never had like any connect. So after some time, I just disable it. The other ports just give enough information. Actually, could just the first 4, as you guess, like they're like the ones who give you the really nice information. In addition to just like connecting, I had one small addition which I had for my iPhone scanning project left over. Is if port 22 connects, a script will connect and try like the 2 default passwords and just run the small line to actually just get a fingerprint of the device. Yeah, this is already kind of like borderline what you should not do, or but I just grabbed like to see if to like do device counting based on MAC addresses. I never actually looked at the data myself. It's just like completely scripted. But it turned out that at some parts, when you don't look at iPhones or any iOS device, you actually find interesting output there. If you just like grab for like certain strings, and then you find some interesting things, but not something that's really like that should arise serious ethical issues. Yeah, basically I just like split up the IP address ranges, ran the scanner on a bunch of machines, and then every few weeks I like checked just to see if everything is still running, if there is some stuff inside the files, maybe I have to like do some adjustment, and then yeah, you do other research on the side. And then at some point, yeah, you try to give a talk, and I'm still like in the process of actually publishing a paper or actually writing the paper about this whole issue. So yeah, about responsibly disclosing some data. I didn't tell too many people about like the real deep details about this. Yeah, some stuff looks a little bit scary. So I stripped out like IP addresses, names of mobile operators, and some points I just like do not show what I found with because some things were like really critical, and I still have to like find like the appropriate people to like report stuff to, and so yeah, but you will get an idea of what that might be or might not. I won't confirm or deny anything about these specific targets. So a raw piece of output from my scanner basically looks like this, very straightforward. So you have IP addresses, timestamps, port open, close status, and like a banner. So nothing, nothing strange. So I ran this scanning for some time, and then of course at some point you say, okay, I had collected gigabytes of data, and now I have to like do analysis. Of course you can always go and like look at the data by hand, and you find like all the nifty small things, and you like giggle a little bit, but that's not going to cut it on a large scale. You can also like just grab for logins or welcome or authenticate, but you have to come up with some automation criteria. Also at some point after like doing the automated or hand analysis, you will want to go into like verify some things. So Google product IDs, maybe just connect to a service to check the banner again. But yeah, do not try to like really interact with devices, because users not get into any trouble, and we don't want to break anything. We just want to like get some information. So for the automated data analysis, I just wrote a like very simple fuzzy cluster matching thing, which basically like strips out version numbers and from the banners, and then just like builds like clusters around each banner, so I just could like count. Yeah, and sometimes, yeah, so what I forgot to say is I've scanned all of the IP address ranges multiple times in order to like determine if like maybe an IP address is like static. So maybe if I always if I find the same device within 3 weeks or 5 weeks every time I scan again, it's likely to be static. And if it's static, it maybe has a special purpose, because you don't normally do that very often on mobile networks. And then you do more post analysis, identify devices, identify the software that is running. If you do not manage to directly identify a device, So banners, they basically tell you what software runs on the device. And these are the parts I looked at. And another disclaimer, so these are just devices I found while scanning. It's really just examples. I don't want to discredit any manufacturer or specific operator. They're just devices I found to show as an example. So in my list, I also scanned for zip on the zip port, but I actually just had one hit, which was really strange. So I just didn't bother to look at zip any further. Maybe in the future it's becoming more interesting, because LTE and everything is completely based on zip. But for now, this is the only slide I have that mentions zip in any way. So first I'm gonna bore you with some boring statistics about what kind of banners I found how many times. So these kind of FTP banners, they're totally uninteresting, because they don't tell us which software. Maybe you're able to cut down this specific banner, one of those specific banners, to 3 or 5 different pieces of software, but it's not interesting. But you have the only interesting thing is you have a lot of FTP servers running on mobile networks, wherever that is. But if you look at the number, the devices that appear not that often, you actually find a lot of interesting devices. And I'm going to show you some details throughout the later part of the talk. So for example, down there, it's this is some industrial application, which I'm going to show you later. So these are all small embedded things. This one is pretty interesting, which I'm going to show you. So basically, you weed out the devices that show off a lot, and look at the devices where you only find a few hundreds, or maybe just in the tens of devices. So one of the first devices I found was this DigiCore Solo, which is a vehicle tracking application. I identified something above 200 devices, and it's basically a tracking device. That should be should really be that device. I try to hunt down more pictures, but So this stuff gets deployed in delivery trucks, rental cars. Maybe you put one in your own car to just track it. But this is a really common application. If you continue and look at more FTP banner stats, you find interesting devices like this. So basically, I found this connection string, which comes down to this company, which basically builds inventory devices. So if you have big storage units, or maybe like delivery companies, they have these kind of devices, and you can actually find a bunch of those on the public internet, and they're all run Windows Mobile. So it's not directly and that's not Windows Phone. It's Windows Mobile. So from 2004 or something. So a little bit older devices. The main applications, of course, supply chain management services. So it gets kind of interesting what you could do if you have access to a bunch of those devices. Yeah, and then I found a bunch of just other Windows Mobile devices, and yeah, Windows Mobile is seems to be still pretty popular in the industrial area. So yeah, if we look further, there are more like embedded SDKs where I couldn't just identify the actual device. I could just identify, okay, it's like an SDK or included with like hardware to like build specialized embedded systems. Yeah, and those are like two popular devices or two popular SDKs which I found. Yeah, if you look further and if you go down and actually look at devices where I only find like 20 or 30 devices, you find stuff like yeah, industrial grade like measurement instruments, like this is combination of like GPS and laser measurement systems that yeah used to like yeah when you go outside and like try to measure like big properties. Yeah. You find stuff like that, and yeah, they all run FTP. I don't know what you can exactly do with these kind of systems remotely, but I just haven't like connected to them besides like grabbing the banner. But it gets more interesting. Yeah, when we look at like M2M communication devices like this. Yeah, this is like I don't know, a small card which you put into some also industrial thing and put a SIM card in it. You see like some antenna and yeah, here's some yeah where you like plug in some cables. And yeah, these devices just like yeah appear yeah randomly yeah on the internet. So more interesting. Yeah, and if you then go and look at devices which are like higher in the numbers, you find this yeah industrial GSM GPS routers, which is basically a bridge between GPRS and Ethernet. And yeah, from the manufacturer's website of this specific devices say yeah you can hook up yeah, surveillance systems, PLCs or ATMs. So yeah, there's a pretty good imagination what you could find behind those devices. Yeah, so yeah, if we look yeah further down the road of like this of the FTP stuff, you find devices from companies like National Instruments, which build yeah basically measurement equipment, and now it's the correlation of the scanning results become a little bit more interesting, or the need for correlation, because sometimes you find you have a few hits of that, and then you have like many of that, and then but yeah you cannot like put this to anything besides the case if you finally find one device which has both, and then you actually find okay I have like 400 plus devices from National Instruments and in many countries. Yeah, and it seems like big and very expensive measurement equipment. Yeah, I don't know which kind of device that was actually. So yeah, FTP gave us some pretty interesting results, but it gets better if we look at actually what the telnet ports give us. So what do we have here? Yeah, so we have a bunch of, yeah. So these on-cell devices are pretty interesting, and sometimes it's like just like yeah a 3G router. So, but if you actually look at the actual data, it becomes more interesting. So this is something very well expected. 3G routers, very common today. Plug in Ethernet SIM card, you have internet. But there are more interesting things like environmental sensors, which are just deployed somewhere in the field and collect, for example, like how much rain is falling, what's like temperatures and things like that. Yeah, you find a bunch of those devices too. Yeah, and then it becomes a little bit more interesting. So this is a big yeah, traffic control, like for street traffic. It's not internet traffic. It's like that's like at the end of like some highway somewhere, probably in Germany. So this is, and apparently this device we're talking about, the actual TMC, I think this was like this box. So I didn't take the picture myself. I googled the picture, just to be clear. Yeah, you can actually find it by like looking for this TDS. And these are a little bit more interesting things you find, because it's probably not only monitoring, but it's also probably also like traffic lights for intersections and things like that.
So these are all passwordless logins, or?
I didn't log in. Oh no. No. Yeah. And the interesting part about this one is it actually, I scanned it multiple times. It appeared multiple times on the scan log, and it had a static IP address. So yeah, it's something that would be there. But yeah, in a third scan and by manual verification, it was not gone. So I just tried to grab the banner again, and it was gone after, I don't know, a few months. So it's not online anymore. So but it's one of the more interesting finds. Yeah. So doing the same, just like fuzzy clustering on HTTP. We have this. Yeah. Just the average like micro, mini, generic HTTP servers for embedded systems, and just tells you what kind of software is like really common on those devices. But again, if you look at those banners that are not too common, you find a lot of like high grade, like yeah, professional, like 3G routers. Some more of those bridges, IP cameras a lot, and this little device, which is going to be interesting. This is yeah, basically a system for like home automation. You put it somewhere like in your basement, and then you can do like remote management of your house. So apparently the website said something like, hey, you can like log in and like turn off your lights, like control the heating and everything like that. And it's basically reachable from the internet, and these devices I found like in a Russian network. So I was talking a little bit about those GPS tracking devices, and that's really a common application today. So it's like in rental cars, delivery trucks, maybe when you ship like a really valuable item around the world, like in a big container, you put devices like that, like into the container to just see where it goes. And yeah, I talked about this like DG Core Solo FTP banners thing before, but there is way more. So one device I came across was you connect to Telnet and immediately starts like printing out these strings. And so north, west, that looks pretty interesting. But for this kind of output, I only had one hit. So, but if you throw it in Google Maps, you directly like end up on a highway somewhere in Portugal. So it's pretty clear that seems to be like a tracking device that's currently like en route somewhere across Portugal. And yeah, so the country actually matches, or the coordinate matches the country of the operator. So it's pretty clear that it's like some vehicle like moving on some street. And then if you take some substring from these and like just search partially or search the substring over like your big database, and then you get like some matches here, then you actually find about 100 more hits of those in other countries too. So this is the kind of manual work I had to do to actually find more interesting or devices. But there are more devices, like the C4D device, which just prints like this very boring welcome message. I found like, about 180 of those devices. And yeah, if you actually connect to one of those devices, you immediately get thrown into like this menu where you can also say, hey, give me your last GPS coordinate. Like, I didn't type any command, I just connected to it, took a screenshot, disconnected without like entering any command. And actually, the funny thing is, on their website they have exactly this screenshot, like not exactly the same, but this screenshot to actually show, hey, that's like a super or open system and you can do everything, it's so easy. This is, if you wonder, this device, so I guess that's like you connect it to the car, there's your antenna. This is one of those devices. So so this GPS tracking is like, there's really no surprise that you find a lot of those devices on the internet, and most of them are not really secured. It would be really interesting to like do a specific detailed study on just like finding and maybe abusing tracking devices, and especially if you're able to retrieve the coordinates where these devices are, maybe you find devices at really interesting locations that are like reachable on the net. But that's something for a future project of mine. Yeah, so you see we're slowly moving up the ladder. So now from Telnet and HTTP to SSH, and so down. The two most common or very common HTTP daemon or services I found, of course, OpenSSH and Dropbear, which are for especially Dropbear is like in the embedded community like widely used. But there's also a bunch of smaller installations. One of my favorite devices I found was this like Moxa on-cell device. It's one of my favorite because it's like deployed from the devices I found in the most countries. It's kind of an interesting application, and often you get like root shells without passwords. So you connect to port 22 using the SSH protocols, then directly get dumped into a shell. This is from like the script, this automation script, because I also called uname, you just like see what kind of Linux runs on those devices, and if you just grab for on-cell on the database, you find like a number of different versions. On Telnet, like the Telnet banner, more or less looks like that. So this looks like also like a menu system. But I just pulled that from like the scanner, so I didn't actually bother in reconnecting there, because if you verify that you have a root shell without password, who cares about the Telnet interface really? So finding a number of devices is pretty interesting, but if you actually like look into what these devices are made for, it's a little bit scary when you see, I just like had a root shell on something that's like for power automation somewhere in some remote country, and you don't want to crash a device like that by scanning, because you don't know what it's actually connected to. Also, you actually probably don't want to hook up this kind of device to the internet without configuring any kind of security into it. And it was not just one device where you just got a root shell. But there are like more Linux-based devices that just sit there, and you get shells on. And this is just another like M2M router or gateway, which I found. The same goes with like these professional routers. You find a bunch of them all over Europe. something I recently, or at that, when I started that, I found and I got like a little bit more interest in were smart meters. So basically a smart meter is something, a small device that like sits down in your basement and where your main power is connected, and it like basically records the amount of energy you consume. And it's in the future it's also built so you can remotely regulate like your power usage. So maybe you want to use like wind energy, and then you only want to like start like a device like your washing machine while you have like getting power, like cheap power from like a wind farm. So these devices could be potentially pretty powerful. And then you scan and find a bunch of devices. So the small number of devices is probably due to these kind of devices just being like deployed, and maybe there were even like test installations. But yeah, so one of those devices was this like Dr. Neuhaus device. Again, you just like end up on a root shell without providing any password. And you actually see here like your small GPRS antenna and like all your inputs, and then you have like your meter signal, and your WAN interface. So, and that looks like another device. So this small device like this sits in your cellar, and like people who can operate I don't know, SSH like own it without doing anything. So that's not really what you want. And then by looking further into things, so this device didn't appeal to me in any way by just going through logs. And then at some point I just like grabbed for admin, and then I saw this administration terminal, and I don't know really why I was going after that device, but at some point I just like, okay, let's see what this device is, and it actually turned out to be also a smart meter. And so the default password for this is 1234, which like hackers read documentation. So that's just listed in the documentation. No, I didn't do any brute forcing. And this is really one of the rare devices where I actually logged in manually just to see what is. So I just like just basically you get like this command interface, and then that's like the only thing that's like was where I was not behaving nicely, but there was no shell, so I disconnected and just made a screenshot. As I said, like the smart meters are most likely like test installations. Hopefully, like units like that just are not field deployed. And they're all Linux, so. And run SSH, and it could be very easy to like just like build some, I don't know, small like smart meter botnet. It wouldn't like do anything really. Maybe you can like turn off like the lights of like a neighborhood, but it's not that you can DOS something over like a GPRS connection or so. And it's not like interfering with like your local Ethernet. So you probably cannot even like host like a rare site on those, because maybe you have like 2 megabytes flash or something. But the main issue here is like these devices are just like being deployed in the wild, and so in the future those devices could be a real problem. At the end of the talk I can give you some more insights. I talked actually to some guy who's like working on deploying these, and if you hear some of the stories, it's not too amusing. So I found like a bunch of more like general purpose M2M platforms used for either GPS tracking, telemetry data, and you find a lot of more devices where you just like get root shells on things like that without doing anything. And yeah, it's kind of interesting. Like each manufacturer of like these like small M2M gateways seem to have really a local market, because here you see this one is only in France, the other one was only in Germany, the other one was only in Belgium. So there seem to be like small companies who make like specialized devices, and which are like popular in certain regions. That's one of the small learnings. And now back to my like initial project. It was like, yeah, finding iPhones, or now like iOS devices, because you also actually find a lot of iPads. So one idea was like, hey, can I actually count how many like jailbroken devices I find? And of course, you only find if like a jailbroken device has like SSH installed. So through all my scans, I like identified like 500,000 of like unique devices, but yeah, from these there were only like 2,000 had like SSH installed, so not a too big issue. It's not like there is not going to be like a new like IKEY worm that like spreads around. Also, probably most of like like actual phones or iPads or other devices like that sit behind like NAT gateways. So that's probably also one reason why I didn't find too many. The only thing, like as I said, like probably not a second worm. But what if you want to do like SMS fraud or steal data? You can still do that if like SSH is enabled with the default password. So you don't have to like write your Trojan, upload it to like the Android market. You just like find like a couple of thousand like iOS devices and just like go and like send 10 SMS messages from each, and then it's the same as like installing, like having people install like devices. You can just do it fully automated. Or if you just want to have like anonymous like SMS sending or mass SMS sending, that's what those devices could be used for. Yeah, and then if you combine with Tor, is like, yeah, as long as you don't send like SMS messages to your close friends, you maybe be good. But so this is like the only issue that like actually stays with those jailbroken devices. Yeah, so I had a number of like really strange finds. That was like, one was like a Beagle board, which is like a small embedded ARM board, which is normally used like for developing or toying around. But I found like above 20 devices like hooked up to some network, and of course you have root access, but it's just like a development platform. So probably some people are just like playing with those and just like keeping them connected because it's yeah, like GPRS is so cheap these days. But the interesting part, yeah, I found like a small like surveillance network, and so the interesting part. So this is like a Class C network, and you see like a bunch of devices, and it's like 38 cameras. And then you have like one camera server. So somewhere in Turkey there is like a small like surveillance network like hooked up to some mobile operator. Yeah, I didn't like try to like get to the video streams or anything, but yeah, it just you just find like this all like FTP, yes. Yeah, so this is like the more like some stranger finds. Yeah, so in the beginning the question was, yeah, phones, but it's not phones only. You have smart meters, you have professional measurement, GPS stuff, vehicle tracking, like industrial power control, more vehicle tracking, supply chain management devices. And I really think that the stuff, a number of devices I found is just really as the typical peak of the iceberg, the tip of the iceberg, because sometimes you just don't see certain things because operators don't, like for example, tag their net blocks as GPRS usage, which is for this kind of research a really big drawback. I of course could just like scan the whole internet, But yeah, that takes a lot of time. Also, operators might, I only scanned operators that were handled by RIPE, so only this like European, I think it's mostly in Europe. So of course I didn't scan operators like in the US or in North America or neither in South America, which is kind of good if you like go to the US and give talks about this stuff. Some net blocks are only used like for NAT, so a large portion of scans just terminated in HTTP proxies, which are probably like sitting on the NAT devices. I guess a lot of devices just don't have open ports because they don't run services, especially like mobile phones. As I said in the beginning, they just don't run services. But of course, I could just have like, made a mistake and just like fucked up at some point, and that's why I didn't see too much. So some takeaways for you guys. For one part, what kind of embedded software is used like in the field? So what like software stacks, what platforms, maybe what a single application. Some people have to like check them out for features, behavior, default credentials, vulnerabilities, and there are probably a lot of really, really easy targets. So it's kind of like, hey, what device to pick for your next research project? It's one takeaway. So my basic conclusions are that like mobile networks are really full of interesting devices. It's like mobile phones are a lot of fun to play with, but industrial or big enterprise deployments and for certain things are way more interesting. Most of the public IPs that are probably used for M2M, so machine-to-machine communication devices. For what I see so far, like static IP address assignment seems like really, really rare. There was like this basically one or two incidents where I really saw like some device having always the same IP. There are like a bunch of different M2M devices, and so far like security doesn't play a role in any of them. Basically root shells everywhere. And now the one of the bigger problems is like so this mobile hardware and especially like all the stuff that's connected to GPRS, it's like super commodity hardware today. Maybe it's one module is maybe $5 and you can put it, and it's going to just be put in any kind of device. And all of these devices are then suddenly connected to the internet. And the real big problem is if those devices are often like put in appliances that are somewhere in the field. So if you cannot really update firmware remotely, then if something gets owned, you have people like driving in trucks to somewhere outside and like repairing those devices, and that could be a really big problem, especially with like regards to smart meters. So I talked to somebody who's like into smart meters, and he basically told me the smart meter gets certified for one firmware version, and then you're not allowed to update this firmware version. You have to like take a new smart meter, take all your old smart meter out, put a new smart meter in with the new firmware version, because remote updating is not allowed, because it's this device is is certified that it counts the number of watts you're using in your house correctly, and so you're not allowed to like tamper with it, and the operator is also not allowed to like install updates. So this is probably going to be a big problem if those devices are even a little bit insecure. And that's it already. I hope you could take something away from it. I'm done.